In this lesson, I will teach you about the 5 different types of chemical reactions that you'll need to be able to identify by looking at the chemical equation. The diagrams on the left-hand side, those are there for a visual to help you better understand. And then as we continue, we'll practice them together to see if we can identify what chemical reaction is being represented by the chemical equation. We'll start at the top, synthesis reaction. We're going to start right here. Okay, a synthesis reaction is a reaction that has 2 reactants that combine to make one product. Okay, so this is a reactant, this is a reactant, and then they combine together. So it's A plus B, and then they got one product, which was AB put together. Okay, so synthesis means to make. In biology, you've heard of photosynthesis. Use the light energy. There's also chemosynthesis, and you would use the chemicals for energy. So synthesis means to make. You're going to be making a product. Okay, so you had 2 reactants, and then they came together for one product. So the clue is that you have one product, and they combine. So they give you an example right here. So they had Na plus Cl, and after the arrow, they combined to make one product. One product, reactant, 2 reactants. Make that a little bit. Let's go ahead and take a look at the next reaction. This is going to be decomposition. When you think of decomposition, what do you think of? Maybe you think of something rotting or falling apart, decay, and that is similar to what the description is going to be. So for decomposition, you're going to be right there. You start off with only one reactant, okay? So the original substances, one reactant. At first they were together, and then after the arrow, you produced 2 different products because they broke up. Okay? So I'm going to say that one more time. For decomposition, you start with one reactant together. They are combined. And then after the arrow, they break up. And you're going to have 2 products. So the clue for this one, when you see a chemical equation, if you only have one reactant, then you already know it's going to be a decomposition reaction. So take a look at the example, which is right here. We have one reactant. After the chemical reaction happened, after the arrow, it produced 2 products. It separated. You started with H2O together as a compound, and then you separated the H and the O. You know they separated because you have the plus sign. The plus sign lets you know that they are no longer one compound, they're 2 separate compounds. So that was synthesis and decomposition. Now we're going to go ahead and look at single replacement. Okay, let's look at this picture really quick. For single replacement, you have an element and a compound on both sides. Okay, let me show you what that looks like. An element is just one letter all by itself. So this would be an element. Let me change colors. This is an element, it's all by itself, letter A. Plus a compound. A compound is 2 elements put together. This is B and C, and they're together. Okay, so it's an element plus a compound. I'm going to put the letter C so you know that this is a compound. And afterwards, you still get an element because it's one letter all by itself, and you get the compound. So on both sides of this reaction, this is the only reaction that you have an element and a compound on both sides. As we get further into single replacements, we will learn that one element is going to replace the other. That's why it's called single replacement. Okay? The letter A will replace B. as you can see right here, we're getting a little bit ahead, where A will replace B. Originally, the reactant started with B was with C, but if you look over on the product side, now A is with C. Okay, single replacement is one element. That's why it's called single, because it's just one element replacing another. And the clue for this is going to be an element and a compound on both sides. This is the only one where you will have an element and a compound on both sides of the arrow. So if we look at the example right here, we have our compound. Those are two elements put together. So we have our compound here. Then we have our element. After the arrow, we have the same thing. We have a compound and we have an element all by itself. This is the only chemical reaction that will have a compound and an element on both sides, and it's called single replacement reaction. Let's go ahead and look at the double replacement reaction. If single replacement was one element replaces the other element, double replacement is going to be that two elements are going to switch places. First, let's recognize the clue on how we're going to be able to identify it. The clue is that you will have a compound on both sides. Remember, a compound is two elements put together. So, this is a compound, this is a compound, and then after the arrow, this is a compound and this one is a compound. This is the only reaction that you will see that has two compounds on both sides. So that's your clue to be able to identify it. Let's look at the example down here. Zoom in. This is what it would look like. Double replacements are also the longest usually in equations because it has the most symbols put together, the most elements are together, so it generally looks pretty long in comparison to the other ones. So let's take a look at this equation right here and let's identify the compounds, because you will have two compounds on both sides, and that is how you're going to be able to tell that this is a double replacement reaction. Here's one compound plus this compound. Now after the arrow, here's one compound plus this compound. And that one is called double replacement. Now there's just one more. If you need to pause it here, you can. The one that only has one reactant is going to be something like this, the decomposition. Okay, you start off with one reactant and it breaks apart into two products. A chemical equation would look something like this. Okay, you only had one reactant and then it broke apart. The one that has one product is going to be synthesis. Okay, you started off with two reactants and you came together to form just one product. Synthesis means to make. It came together. They combined and came together. So if you only compound on both sides. Let's go ahead and look at this. If we refer back to this diagram right here, single replacement has an element, compound, element, and a compound. And the clue tells you single replacement, element and compound on both sides. What would that look like in a chemical equation? They give you an example here at the bottom. This is going to be your compound plus an element, and on the other side, your compound plus an element. So a compound and element on both sides is single. Go back. A compound and compound on both sides is going to be generally the longest equation. And that's down here at the bottom, right here. Okay, you have a compound plus a compound, and after the arrow you still have a compound plus another compound. So it will be double replacement. The fifth reaction is a combustion reaction. Also sometimes called fire reaction. If there's combustion, there's some sort of flame, fire. So let's look at this picture really quick. The fuel for a combustion reaction is going to be some sort of hydrocarbon and an oxygen. A hydrocarbon is simply a carbon and a hydrogen put together. There can be a lot of different ways that carbon and hydrogen can combine. So when it says describe the fuel for combustion, you just simply need to know it's a hydrocarbon. Hydrocarbon. And there's 3 examples right there. All of those examples could be correct. If you take a look, it's anything with a carbon and a hydrogen as a compound. What other gas helps fuel a fire? So if we look at our picture over here, we see that there's oxygen gas on the reactant side, meaning that was the original substance to start the chemical reaction, to start this combustion reaction. So the other gas would be oxygen. And the biggest takeaway here is that combustion will always have 2 products after burning, carbon dioxide and water. Okay, so in my opinion, these will be the easiest to identify because after the arrow, no matter what, okay, in all the equations, we've already learned there will be an arrow. You will always have CO2 plus H2O. That will always be in your products. So as we're about to do some practice ones. As soon as you see that as a product, you already know it's combustion. And we'll practice. I'm going to recap the 5 chemical reactions. The first one we talked about was synthesis. That's when 2 reactants come together to form one. The second one we talked about was decomposition. That's when you have 1 reactant break apart and you get 2 products. Single replacement, that's going to be when you have an element and a compound on both sides of the arrow. Double replacement is when you have compound plus a compound on both sides of the arrow. And combustion. For combustion, you're always looking for the product to be CO2 and H2O. And that's the very last one we talked about. Right there. Okay? The product will always be CO2 and H2O for combustion. So here's a little cheat sheet to the right. Out of these chemical reactions, which one only has 1 reactant? If you want to go back. So the answer to the very first one is going to be decomposition. And I might abbreviate. Put decom, that's for decomposition. Which one only has 1 product? Then that's going to be synthesis. Which chemical reaction is always going to have carbon dioxide and water as products? Combustion. I hope you knew that one right away. Let me go ahead and write that. Going to have to abbreviate and leave it at that, right under space. Okay, so that one is combustion. Which one will have an element and a compound on both sides? An element I'm going to abbreviate. A compound and a compound on both sides. Okay, let's practice identifying the types of chemical reactions together. There are some abbreviations, since some of them can be very long. You can go ahead and pause this if you want and attempt to do some of these on your own, or go ahead and follow along with me. So the chemical reaction that only has one reactant, that means you just start with a compound and it breaks apart. If something's breaking up, that's going to be decomposition. The chemical reaction that only has one product, that is going to be you made something, you brought it together, they joined. That's going to be synthesis. I'm going to show you what it looks like. So for decomposition, you only had one reactant, so let's say it was A, B, and then after the arrow, it was A plus B, because they broke apart. Now for synthesis, we only have one product, so it's actually just the reverse. You started with two reactants, and then after the reaction, you got one product, meaning that they combined. Number 3, an element and a compound on both sides. It's going to be single replacement. A compound and a compound on both sides, double replacement. Which one was called the fire reaction? Combustion. And always remember, for combustion, it's very important. The product, that means after the arrow, will always be CO2 plus H2O. I find these the simplest to identify. Maybe you will too. That's always the product, okay? So going through these problems, let's look at number 6. Right away we see one. Look at the product. CO2 and H2O. If you see that, you should think combustion. That is a combustion reaction. Number 7. Okay, so I see one reactant and then the arrow and they broke apart. Now I see two products. So if something's breaking apart, it's decomposition. Okay, decomposition is number 7. Let's look at number 8. Okay, this might take me a little longer. HCl, that's two elements put together, hydrogen and a chlorine, so that's a compound. NaOH, again, that's going to be a compound. After the arrow, NaCl, compound, compound. A compound is going to be when there's more than one element grouped together. So this is a compound on both sides of the arrow. So is this going to be a single replacement or a double replacement? Hopefully you said double replacement. Let's go ahead and take a look at this one. This is an element. It's all by itself. And it's a compound next to it. So this is an element. This is a compound. On this side of the arrow, this is a compound. And this is an element. Element and compound on both sides of the arrow are going to be a single replacement. Last but not least, take a look at this. You have two reactants. A reactant plus a reactant came together to give you one product. Okay, they came together, they joined, you made something, and that's going to be synthesis. I hope you enjoyed this lesson and this helped you get a better understanding on how to be able to identify the 5 different chemical reactions.